understanding urban weather.
You can see quite well that London's there, but you couldn't, for example, see the river or parks or anything like that.
And nature lends a hand to cutting climate emissions. But for how long?
Nature has helped us to cut the rise in concentration of greenhouse gases by the amount that we need to do ourselves.
It's Friday, the 14th of January, and you're listening to Weather Snap from the Met Office. Hello, I'm Clare Nasir, and this is Weather Snap, an insider's guide to the week's weather headlines. This week, the Met Office released its 2022 carbon dioxide forecast, detailing background levels and predicted emissions for the coming year. A concerted effort to reduce global CO2 emissions is vital if we are to reach temperature targets and avoid the worst effects of a warming climate. This year, that effort may be bolstered by natural forces, as climate correspondent Graham Madge explains.
So what we found is that the carbon forecast, which we do on an annual basis, this year will be just over 2 parts per million of carbon dioxide being added to the atmosphere. That is going to be a challenge because, as we remember, going back to COP last year, the big climate science conference, there was this emphasis on staying below 1.5 degrees. Now, every part per million of carbon dioxide that we add to the atmosphere is obviously adding to that burden. Society needs to find ways, if we're to adhere to that target. It appears, though, that this year, although the level will be about 2 parts per million added, that nature is actually giving us a huge helping hand this year because of the way tropical forests and other vegetation and the oceans draw down carbon dioxide. It actually seems that nature on the planet is actually giving us a hand. We think that the reduction in parts per million will be about a 20% reduction this year compared with normal years. And that's the sort of target that we should be aiming at if we are to achieve adding no more carbon dioxide to the atmosphere by the mid-2040s, something like that. But we can't keep relying on nature to do this heavy lifting for us.
And the reason why we're seeing a reduction is because of a huge atmospheric pattern called La Niña, which doesn't happen every year, does it?
That's right. We have this huge area of variability in the tropical Pacific, known as ENSO, the El Niño Southern Oscillation. And you're quite right, we're in a cool phase of that variation. So it oscillates between some years are very warm and the ocean imparts a lot of heat to the atmosphere, which obviously tends to raise the planet's temperature. But in La Niña years, the opposite happens. There's a slight cooling, and that cooling is having an effect on tropical vegetation because it means that forests are not as inclined to dry out as much as they would have under El Niño conditions. And also there's likely to be fewer forest fires, which would add more emissions. So when you take all those things into account, it looks as though we are going to get this helping hand from nature this year. And indeed, the Met Office's forecast was designed very much to try and see if we can understand more about this relationship between warmer years and cooler years and the impact that that has on natural vegetation.
Let's just backtrack a little bit because we're talking about such tiny amounts of particles which we're measuring, and we are saying, right, okay, across the whole world, currently CO2 is at this. So currently it's approximately 416 parts per million. Why can we measure it so accurately?
There's been measurements since 1958 taken at Mauna Loa in the Hawaiian archipelago. And the reason why Hawaii has been chosen is it's really as far as you can get from major sources of emissions. So by the time the air gets to Hawaii, it will be more thoroughly mixed, and therefore you get a truer representation of the atmospheric concentration of these gases. And what's been noted every year is that there is this step-by-step rise, and it's called the Keeling curve, named after the scientists that did the first monitoring there. And every year scientists have been doing this monitoring. We've seen from their figures that the concentration of carbon dioxide in the atmosphere is not only rising, but the rate at which it's being added to the atmosphere is also rising. Back in 1958, there were about 316 parts per million, and it was rising at about 1 part per million per annum. By the time we get to more recent decades, the last few years, we're actually seeing that rising to about 2.5 parts per million. And we need to see that starting to slow. And scientists have worked out that if we can keep peak concentrations of carbon dioxide at around the level of 440 parts per million, then that should enable the planet to be on track to limit warming to 1.5. But of course, if the concentrations of carbon dioxide in the atmosphere keep rising, then global temperatures will broadly keep pace with that and will keep rising in tandem.
So La Nina is a temporary phase, and we could go into an El Nino next. So really, we're not out of the woods in any shape or form, despite this temporary 20% drop, and we still have to curb our emissions massively.
It's an interesting coincidence that nature has helped us to cut the rise in concentration of greenhouse gases by the amount that we need to do ourselves. But we can't expect nature to keep doing this by providing a helping hand for us each year. And we need to make drastic cuts in that if we are to achieve the target and keep the 1.5 alive.
Graham Madge talking to me earlier. On any given day, weather conditions in towns and cities can be very different to open countryside or coastal areas. When conditions turn extreme, accurate forecasts are crucial, but these types of events may be short-lived or very localised. The answer for meteorologists is to produce finer scale models, and a new project by the Met Office aims to do just that. Here's Met Office Head of Urban Scale Modelling, Dr. Humphrey Lean.
What we're really talking about is reducing the grid size from 1.5 kilometres, which we have at the moment, to the scope of the project is grid sizes between 50 to 300 metres. So that's over a factor of 10 higher resolution. A lot of it is to do with cities, how they should be represented in the model. So at that resolution, you can actually start to see details within larger cities. The current model, you can see quite well that London's there, but you couldn't, for example, see the river or parks or anything like that. And how you actually represent the cities in the model is a really important problem, and it's a really difficult, complicated problem because there's lots of different structures on lots of different scales that you've got to try to represent. But I should say it's not entirely limited to cities. I mean, we're also interested in non-city effects with these models. So, for example, convection, sort of thunderstorms, etc., they're barely represented in the current models. If you think that typical thundercloud might be 10 kilometers across and the smallest squares are 1.5 kilometers, then you're not really representing those very well. And particularly, all the details, all the structures within those storms that cause them. So we're also hoping to improve those forecasts a lot with these urban scale models.
That's really interesting, and something obviously would help a lot of people. When it's windy in a city, you do get that sort of squeeze of the wind, and the winds can be a lot stronger locally just round a corner of a building than, say, open countryside.
That's partly why this is a very difficult problem. If we go to a 100-meter model, for example, we're still not going to properly resolve all the individual buildings. So we still have to find a way to represent them without actually resolving them, which is what we do in numerical models for all sorts of processes. So it's not a new thing. But it is, it's fundamentally quite a difficult problem. Plus, the other difficult element to it, apart from the pure maths and physics aspects, is that it involves human behaviour to some degree. You need to know about the heat generated by the various things going on in the city. And in order to understand that, you need to know things about patterns of commuting, etc., and what sort of building people are in at different parts of the day, etc. So it involves human behaviour and moves a bit towards social science as well.
This is so exciting, and it's important work, particularly when we're talking about climate change and the stresses that people in cities are affected by. Who will be using this urban scale model? It's not only just for people like us who just want to see the forecast every day.
No, I mean, obviously a part of it is what you just said, that it'll be used by the forecasters. So, for example, if there's a heat wave going on and they want to know a reasonable estimate of the highest temperatures in the middle of London, for example, it will be used for that. But it will also be used for climate science. So an important thing to understand is how the temperatures in cities are going to change under climate change. We know that as the climate gradually warms, then it's already, hotter in cities, this urban heat island effect that people talk about. It's already hotter in the cities than it is in the surrounding countryside. And, it's a particularly important effect at night, because we know that the lack of cooling down at night is a very important health impact. When we go to these higher resolution models, we can actually start to understand where the hotspots are in individual cities and match that up with the sort of different types of housing stock. So most of the health impacts obviously take place inside buildings, because people who are maybe got health problems are not going to stand outside in the blazing sun. So we need to understand the effect on the buildings and the interior temperature, etc. And the other important element is that we can understand how mitigation might work. So, for example, there's been publicity given to the idea of greening roofs of buildings, so putting plants on the top of buildings to cool them. So you can start to do experiments to say what would happen if you did that.
As a meteorologist and somebody who forecasts every day, when can I get my hands on this data? I mean, what's the timeline here?
The project really is trying to understand what the benefits of these models will be and whether they're really worth running in terms of the benefits that we get. So at the moment, it's quite an early stage. So it'll be quite a long time before you see sort of 100-meter models being used routinely. In the short term, there is a project to have a 300-meter model over London. We currently run a non-operational research model routinely over London, but there's a project to make that into an operational model, which we use routinely next year.
That's amazing. Humphrey Lean, thank you very much.
In global weather news, despite a current La Niña adding a slight cooling effect to conditions around the world, this week Australia saw its joint hottest day ever recorded. The Onslow Automatic Weather Station in the Pilbara region of Western Australia spiked at 50.7 Celsius. Other neighbouring locations also came in excess of 50 Celsius, equalling the previous record set in Mardi, Western Australia, in February 1998. This unbearable heat has extended across much of the northwest of the country and is only expected to wane through the weekend. Well, returning to the UK, what can we expect weather-wise for the next few days? Here with the details, Aidan McGiven.
High pressure will continue to dominate the UK's weather this weekend, keeping things generally settled but not necessarily sunny. In fact, on Friday night, there will be fairly extensive low cloud mist and fog, particularly for parts of the Midlands, northeast and eastern England. Elsewhere, a few clearer spells and certainly a cold start to the weekend with a widespread frost, particularly for England and Wales. I think for Scotland and Northern Ireland, it will be milder here with more cloud in the sky overnight and a bit more of a breeze. But for many, it's a dry start to the weekend. However, the fog, where it does form, could last in places all day, and if not, it will lift into low clouds. So generally a grey picture on Saturday, but in a few lucky spots there will be some sunshine coming through, particularly across parts of, say, Western England and into Wales. But it will feel cold across England and Wales after that chilly start, especially where we get some lingering low cloud, mist and fog, temperatures struggling out of the low single figures. For the far north of Scotland, it's milder here, but it is also a bit breezier, with some outbreaks of rain, particularly later on as a weather front moves in from the northwest. That'll bring a spell of rain, and as it pushes south across the country, well, it's going to tend to fizzle out, so not much rain on it. But it does, by Sunday, mark a contrast between clearer spells in the north and foggier, mistier, gloomier conditions further south across a large part of central and southern England, as well as South Wales. And the low cloud and mist will linger in places once again on Sunday, whilst the brighter outlook remains for northern England, Scotland and Northern Ireland. But for the far north of Scotland, here it will turn windier and there'll be some blustery showers moving through on Sunday afternoon. It will feel cold in that wind in the far north, and it will also continue to feel on the cold side in the south where any low cloud and mist lingers. But for many, actually, it's looking like a generally dry weekend, whether you've got the low cloud, fog or the brighter spells.
Thanks, Aidan. Just before we go, here's Ollie Claydon with last week's highs and lows.
Here are the UK weather extremes for the week Monday the 3rd of January to Sunday the 9th of January. The The highest recorded temperature was on Saturday the 8th at Exeter Airport, with a maximum temperature of 12.1 Celsius. Just a few days earlier, on the Thursday, Topcliffe in North Yorkshire had the coldest night with a minimum of -8 Celsius. Exeter Airport also had the sunniest day of the week, clocking up 6.8 hours on Wednesday. And finally, the wettest 24 hours was at Capel Snowdonia, Wales, when 34.4 millimetres of rain fell during Saturday.
Thanks, Ollie. That's it for Weather Snap. I'm Clare Nasir. Editor is Adrian Holloway.
Weather Snap is a podcast by the UK Met Office. For the latest weather conditions where you are, download the Met Office weather app.